So without further ado, I want to hand it over to Dave Dougal and William Malik, both from EnterpriseWeb, and they will run you through the demo. So Dave, you guys are good taking questions as they come in?
Absolutely. Ideally, we take them at the end. We sort of allowed for time for that. But if you get some questions, and something seems very specific to where we are, I'm happy to attempt to answer it in the moment. But I'd sort of prefer if we can table them towards the last 10 minutes or so.
Okay, no problem. So off you go.
Fantastic. Well, thank you so much, Tom, and appreciate this opportunity with IWPC to present to you and the members once again. So today we're going to actually dive deep into something that I think is actually becoming a hot topic, and it's a sign of sort of growing maturity and awareness of the challenges of both automation and AI, and the need for sort of a common domain model or telecom ontology to provide the missing links for level 4 autonomous networking. And so we're gonna delve into that today, and hopefully it's generally informative. And of course, we're also going to provide a demo as well. So I'm joined by my colleague Bill Malik, who's our chief system architect. So without further ado, I'm going to start off with just a quick intro of the company for those who don't know us. So EnterpriseWeb, we're a no-code AI-powered no-code platform for intelligent business infrastructure and IoT applications. That's sort of a good Gartner category to sort of a box to put ourselves in. Of course, there's probably 1,000 companies that would claim to be AI-powered no-code platform. The real distinction for EnterpriseWeb is this no-code, no compromises. We were built for distributed systems engineers. We were built for network engineers. We were built for solution architects and data scientists to build complex systems, not just to do sort of citizen developer apps. And you'll see that through in the demo itself, sort of the richness. Our goal is to make very difficult things much easier to do and manage. So EnterpriseWeb itself is agent-based, ontology-driven, and we use serverless tools. So EnterpriseWeb has always been, it's sort of core of our IP, is we use agents that sort of self-organize around and respond to every event and request of the system. And these agents use an ontology, and we're going to explore that in great detail, but they use the ontology as opposed to just using an LLM, which is not a great source of intelligence. It's not necessarily consistent. It's not necessarily accurate. It's not necessarily explainable, and it's certainly not efficient or secure. So EnterpriseWeb's agents instead, we put an ontology on top, and the agents use the ontology to interpret events, evaluate conditions, automate decisions, and optimize actions. And as part of that, they can call tools. So that's now called function calling or tool calling. And they can also call LLMs or AI algorithms to fulfill a request or command or a query. So EnterpriseWeb's technology is now 23 awarded U.S. patents. The core of our IP, we're not going to dive down to this layer, but is actually hypergraph-driven metaprogramming. That's just this highly abstracted level of working. It's how we handle the complexity. Sort of hide that complexity, abstract the complexity away from the developer, from the engineer, from the solution architect. And it's called hypergraph-driven metaprogramming. And hypergraph just means it is a special kind of graph in computer science that supports complex, multidimensional, and conditional relationships. Hypergraph can support more than just data. It can support data and behavior in the same graph. So it's very distinct from things you might know with semantic web or labeled property graphs like Tiger Graph or Neo4j. And I just came back from a conference, and presenting these ideas to that very community. And, we're really addressing gaps in the graph community. So the question, so EnterpriseWeb itself is a telco virtualization automation pioneer. We ran the first Etsy NFV and Etsy Zero Touch POC, won a series of TMF Catalyst Awards. Networks.ai is our telecom solution for intent-based end-to-end orchestration and autonomous networking. So EnterpriseWeb is the name of our company and the platform. Networks.ai is the name of our telco solution. And some of you might be familiar that we've won a host of awards, including most recently from pretty much every major telecom media publisher. So the thesis for today's call is telecom ontologies. The subject is all about telecom ontologies, and so just wanted to set that up. So in a dynamic, distributed, and diverse network, which you guys obviously have, the most valuable business asset is a telecom ontology. This is the sort of central thesis for today's presentation. The ontology provides a common model, or language actually even, for semantic interoperability across heterogeneous elements, diverse environments, and siloed domains. Right? So think of this umbrella abstraction, this sort of common intermediary language for working with for different elements that are speaking in different protocols that might only be partially standards based, that might be deployed in public cloud or telco cloud, that might be running across the RAN core and transport. If you could have a common language that span all of your use cases across all of those different kinds of elements, environments, and domains, then you could really have network visibility and support real network optimization and automation. So the ontology, the whole goal of the telecom ontology is not just to be a model, but it's also to provide a central source of domain knowledge and real-time operational context. If you have a common model, a common language that everything gets mapped in and out of, then that supports sort of this shared memory where the platform can be sort of translating between all of the elements. As a telco operator, as a service designer, as a solution architect, you get to speak one standards-based language, even though all the different elements might be heterogeneous. The cloud providers have different native APIs. So you'll have all of this complexity, all of this heterogeneous aspects, but you're getting this sort of common umbrella abstraction that allows you to work with these things as if they're in one kind of model, speaking one kind of language in one location, even though we know they're distributed and heterogeneous, etc. So the central source of domain knowledge and real-time operation context supports both Gen AI and classic AI. Everyone, I think, at this point recognizes that context is really central and critical for optimizing inferences. Of course, it's logical sense that you like real-time context for intelligent automation, and you want domain knowledge for translating intent, for intent-based orchestration. You need that also kind of domain knowledge and real-time operational context to support AI ops, and certainly for autonomous networking. So telecom ontology, is providing this medium that sort of goes beyond. You're not going to get there with just data aggregation. Data aggregation is an important step. Data cleaning is an important step, and we can work through data aggregated sources as well as directly through protocol interfaces. But by itself, the data aggregation doesn't give you a common language. It doesn't give you a common model of everything, and that's what we're doing with the ontology. So to unleash the value of network data and enable autonomous networking, telcos need a unified and harmonized network model. A standards-based telecom ontology can provide the missing links to connect, query, simulate, and manage operations. And this is just an indicative set of standards that are implemented by our system. And we'll go into these in detail. So what does this look like architecturally? Architecturally, what we're suggesting is that you could have a common model with shared tools and libraries and a unified automation control plane sort of over the top of the network, right? For the last 10, 15 years, the hyperscalers have gone over the top of your network, and they've built services on top of that. Now, actually, what telcos want to do is they want to build more flexibly services over their network. And to do that, you need to essentially go over the top of your own network, right? You need sort of a unified abstraction Obviously your networks have evolved over long periods of time. You have a mix of physical devices and virtualized devices, PNFs and CNFs. You got some 4G in there, some 5G in there. You want to get to 6G. So you got all sorts of real world complexity. But if you treat everything as a snowflake, it's not super productive, right? If everything's heterogeneous and you're going to treat them all like they're individual discrete elements, then the only thing you do is manually integrate them into stacks and silos. And what we want to do is get away from that. We want to introduce a horizontal platform over the top. And that horizontal platform is providing that sort of common domain knowledge or shared semantics, domain semantics, as well as metadata, state and telemetry, both real-time and historical state and telemetry, for the whole life cycle, day 0, day 1, and day 2 and beyond. So just imagine the power if you had one central source of metadata. And of course, it could be working over the top of existing systems. There could be a NAS underneath. There could be existing orchestrators and controllers. Yes, that's all true. But it would be very convenient and useful to everyone involved if there was a single pane of glass from which you can view, compose solution services, and manage them from a single pane of glass over the top. So that single source of truth gives you a unified network view. I'm sorry, didn't mean to do that. Like that. If you'll allow me. Let's see. Trying to close this little window box here if I can. There we go. Great. So it gives you a single source of truth for unified network view of net DevOps automation, end-to-end intent-based orchestration, autonomous networking. It helps you eliminate tool sprawl because in this layer, in this horizontal layer, all of this functionality, which you recognize as sort of middleware capabilities, is implemented as serverless functions. So these are just become tools that the agents can call, that they can dispatch these tools, configure these tools, and coordinate these tools in one horizontal layer. And of course, because they're serverless, they're elastically scalable, they're hyper efficient, you're only consuming them when you need them. Essentially, you're getting to this point where the middleware, the functionality, is becoming sort of self-organizing around the needs of every event and request, as opposed to having stacks of orchestrators all over the place, right? You got to imagine not only does each domain inside a telco has multiple stacks of different versions of different components and different combinations, all of which are tightly coupled together. And then you build your solutions and you tightly couple them to that, and you have to manage all of that. What you'd like to move is to a more horizontal architecture, and that's what this is going to help you do. And it's also providing unified domain semantics and metadata for AI ops. And we're talking about comprehensive AI ops here. We're talking about service lifecycle management, application performance management, slice management, core config, CUDU config, PI config, MAC config, transport config, NIC config, energy management. So we're talking about one layer that can actually understand all of these concepts, understand all of the KPIs, provide a common sort of surface area for agents to do autonomous networking. So this obviously is over the top of your functions and applications across your domains, across the infrastructure, across the CAS and the infrastructure. We're Red Hat, Dell, and Intel partners. Of course, we can work with anyone, but we're tightly integrated into the portfolios of Red Hat, Dell, and Intel. And some of that will come up, of course, in this demo, as we're going to be featuring OpenShift AI and as well as the Granite 3B model for an LLM in the demo. So the unified automation control plane is pushing configs and plans down to lower level domains, and we're pulling up state and telemetry. And it's all being reasoned across by that ontology. The ontology is really that flexible glue of understanding that helps bind the solutions and optimize all the actions taken by the system. And through that, we get assurance, optimization, detection, and prediction. And this gives you a future forward architecture, right? Horizontal, AI first, rich semantics, right? It's falling in line with all the things that are being discussed in 6G, but it's also backward compatible to 4G because that hypergraph can support both 4G, 5G, and 6G concepts, even different versions of different standards in the same model. So it gives you a flexible platform for today and tomorrow. So, ultimately it's going to help you transform, rationalize your solution architecture, consolidate licenses, and accelerate deployments. And I'm going to skip ahead now. In this demo, now, what's the bottom line? What do you get out of this? What you're going to see in the demo, and I'm going to move pretty quickly here, is network in our networks.ai, our telecom solution, the agents are going to enable real-time telco-grade contextual automation. So you're going to be able to, as Bill's going to demonstrate, developers can talk to the network to design, deploy, and manage services. So the agents are going to simplify and automate NetOps. And it's going to be using GenAI NLP. But like I explained, the ontology is really the central source of knowledge and context. We're not leaning on AI for intelligence, we lean on it for inferences. And inferences are just controlled inputs or managed inputs into controlled processes, as opposed to making everything probabilistic. We don't believe that you can run a available, reliable network at 5 nines completely based on probabilities. I just don't think that's going to happen today or tomorrow. It's also going to support autonomous systems. So the agents are actually generating operators, they generate deployment workflow plans, they generate and execute management plans, they dynamically instantiate observability and AI ops, and you're going to see the richness and the depth of what the agents are actually doing on behalf of the developers. The agents leverage, as I mentioned, the ontology to interpret events, evaluate conditions, automate decisions, and optimize tasks. So the agents respond to events, requests, they evaluate the conditions, they generate workflows, they execute the workflows, they deliver payloads, and including providing a trace of every step that they took, of every action that they took, including every token that they used. It's all itemized in a real-time trace and log. For both troubleshooting as well as audit. And so the agents are, able to dynamically compose and configure tasks into complex workflows, call external functions, and fulfill requests and respond to events. This is sort of beyond the current state of agentic, right? We anticipated the problems of the modern distributed systems and networks 10, 15 years ago. And we've been building methodically against this for a long time. So this is not just agents just tightly coupled to an LLM doing sort of light automation with all the risks that it entails and costs that it entails. We're talking about enterprise-grade, telco-grade agents that are not only providing the functional concerns, they're also dynamically enforcing all policies on the fly for fine-grained contextual access control and governance per interaction. So, the whole thing is like, if you can't be telco grade, then I don't think a technology can actually be, really deployed, right? So we start from the presumption that everything needs to be enterprise grade or telco grade to be put, to be reasonably put into production, and that's what we're delivering. So the agents use the Telecom Ontology to orchestrate, optimize, and manage AI. This is very different than graph RAG, right? We're actually saying that the center of the architecture is actually the ontology, not the LLM, right? In fact, we don't think an LLM should ever be the center of our architecture. It's almost irresponsible. And also, we want to support more than one LLMs. So the ontology, and also not just LLMs, domain-specific models, large language models in the cloud, on-premise, et cetera. But we also want to support AI, ML, and RL. So think of the ontology being on top, and the AI are just other endpoints. They're just API calls that the agents are going to make using the ontology, just like a tool call. So this is a very different architecture. And what it does is it allows the ontology to act as a control language over the top of your AI, right? Because the reality is, to optimize your networks using AI, you also need to optimize and orchestrate your AI. And that's what we're doing here as well, as opposed to GraphRag, which, if you think about GraphRag, is GraphRag is like a very diminished graph, which is really just putting tags on documents, and you're just throwing these documents at an LLM in the hope that it actually understands or finds the relevant pieces of information that it needs when you're chunking up that data and sending it to the LLM. But actually, all the research studies show that actually LLMs are actually really poor with that. That it actually doesn't consistently identify the appropriate context out of that. So you're just stuck doing all these workarounds. So when you make the LLM the center of the architecture, you end up building all this sort of flimsy scaffolding around it, which introduces significant solution complexity, cost, and latency. Here we're talking about putting this ontology on top, putting this platform on top, and the LLMs and AI algorithms just become other elements of your solution architecture. And this also is going to allow you to evolve as those language models are evolving too, right? Because you can have one or more models, you can update models just like you update XNFs. They're all version controlled, etc. So, and we're also doing this in a low token, low latency, energy efficient approach, because we're shifting the processing from the LLM, which is super expensive, not particularly accurate or consistent, and it's incredibly inefficient from an energy and resource consumption perspective. We shift the processing to the ontology because that's actually real reasoning, right? It's what's called highly reflective and deeply recursive. From a computer science perspective, it's real deterministic reasoning for very accurate and precise decisions and actions, which is what you want. Because we're shifting the processing to the ontology, it means that we can use the LLMs and AI in a very targeted way. And as you're going to see in the demo, when we're interacting with an LLM, instead, we're not sending 50,000 tokens, we're not sending 150,000 tokens, we're not sending 300,000 tokens. I mean, that's insane. And the more tokens, you have to realize, the more tokens you send per interaction, what you're doing is you're creating a queuing problem, and you're going to get inconsistent, unpredictable latencies from the LLM. And of course, the only way to work around that is just more GPUs. That's the answer to everything in LLMs. We're able to run our demos off CPUs. And we've done that, a lot of demos with Dell, Intel, and Red Hat to demonstrate how we can do CPU first gen AI. But we're only shipping like 3 to 5 tokens, 3 or 5 tokens per interaction with an LLM. If we don't, when the LLM responds to us, if we don't understand it deterministically, we push it back to the LLM with another 3 to 5 tokens, and we do that maybe 3 or 4 times until we can actually resolve what the LLM inference is, and validate it deterministically, and then we could use it safely as an input in a controlled process. So low token, low latency, energy efficient approach to optimizing LLM interactions. So that's it. I'm sorry if I went a little bit longer today, but I really wanted to go a little bit deeper on ontology concepts today, and explain what they are, how they serve your business, how they serve your telco operations. So Bill, I'm going to stop sharing, and you could start sharing from here.
All right. Hey, real quick before while he's getting set up there, just kind of a question to make sure I understand this correctly. So this ontology is sort of a common framework where you're kind of hiding all this complexity and a bunch of different tools and all this other stuff under basically a single interface, right?
It's exactly what it is. And it's very rich because some people would talk about it. So it's not just data aggregation, right? Because we're actually going to work over federated data. We're going to work over aggregated data. We're going to connect to specific devices and elements. So it becomes this sort of this fabric that helps you connect everything. And it has the domain knowledge and the metadata, right? So the metadata ultimately is what's going to get used to essentially plugged in as values into processes. But actually, that domain knowledge is what gives the metadata meaning, and that's what's actually really missing. Not just in telco, by the way. We're talking to major banks and others that are actually struggling with connecting their distributed systems and their networks. Because they don't lack metadata. They're familiar with the data aggregation. What they lack is that ontology, a model that understands their system, so that it ships the right metadata in the right context to the right services, to the right devices, to the right elements, And that's sort of the missing links, right, that I'm talking about is what you would call the semantics.
Okay, cool. So can you actually like eliminate a lot of these tools, or are they just hidden so people don't have to learn, all these specifics about 25 different tools? You're just giving them one good interface that understands everything for them, and then you just use kind of easily understandable commands or whatever, right?
Oh, it's great questions. So, honestly, we've never gotten into a greenfield before, so we only work over brownfields. So we don't really lead with that. What we lead is like no matter what you have deployed, no matter how evolved and sophisticated it is, and you might have some people are pushed NAS quite far. Some people are very happy with their orchestrator or controller, whatever. That's okay. What they generally lack, and I've actually talked to the major NEPs, and they've actually validated that they don't have this either, is they don't have a common unified umbrella across the RAN, the core, and the transport that can do what we just described. So while they might have excellent technologies within the RAN, the core, and the transport, they tend not to have sort of the bridge across them. And so I would say in the first instance, what we're saying is, hey, we're not here to disrupt. In fact, this could be non-disruptive because it's sort of like an overlay, right? It goes over the top as an abstraction, and it's providing this source of domain knowledge and context that we could be serving information to those existing systems, and working with integrating with those existing systems. So that it doesn't have to be about displacing anything. Over time, certainly people can do that. But actually, I think first and foremost, and certainly for the next several years, I think what people are looking for is how do I get to sort of end-to-end visibility? How do I get end-to-end automation? How do I get unified policy control? How do I support AI and autonomous networking at level 4? And that's the problem we're solving for. And you're right, we're abstracting that complexity, which could mean that we're actually connecting to lower level systems, tools like you're suggesting, and or some of that can be being done directly by us or in any combination, right? So it becomes very flexible. So the networks.ai solution essentially sort of fill gaps in the architecture and allow things to connect flexibly.
Hey,
Does
cool.
that make sense?
Yeah, no, that helps a lot. So I just want to make sure I understood it, and just, I'm sure other people had the same questions, but no, that was good. So I guess over to Bill.
All right, Bill, take it away.
All right. Thank you. Can you confirm you can see my screen?
Yes.
Okay, beautiful. So great to be talking to all of you again. I'm just going to do a little bit of setup here. So this demo itself is running on my laptop in AWS. The LLM we're going to use is Granite 3B. As Dave mentioned, there's no GPUs required because we're low latency, low token, and energy efficient. So this is going to be CPU only. And we're also running with OpenShift AI to provide the model hosting and infrastructure management itself. Now, EnterpriseWeb itself deploys as a cluster of pods representing our modules. Altogether, collectively, it's only 50 megabytes footprint, so it deploys into whatever your favorite Kubernetes stack is, etc., or if you want bare metal or VMs, what have you, but 50 meg footprint small. The modules themselves break down along sort of common IT personas for independent scaling and fine-grained security. It's a common technology with shared models, objects, events across each of the modules, and you'll see that because the models that we're going to be working with here in the first module I'm going to show you, the domains, are going to flow into the other tools. So you're going to see all of that. And as I move through the platform, so module to module, I'll call out what module I'm using and what role I'm playing. So we're going to start here in our model manager. I'm going to log into the model manager as a solution architect who's responsible for domain modeling. So as I mentioned before, this is all separate security. So, you're going to delegate this to, obviously only people who can manage the model itself. But what's really nice is that any aspect of EnterpriseWeb that you're using, you get the same kind of common characteristics. So fully declarative design environments that are easy to work with. It's easy to import new sources and create objects. I'll talk about that in a second. But what's nice is extending the security. You also have version control in absolutely every element that you see here. So everything here is going to be safe and controlled. You're going to have strong change management, and you can even do rollbacks, audit history, all that kind of good stuff is all going to be tracked by the system. And I'll go into examples as we go here. But what we're looking at right here is our declarative design environment for models, right? When I say it's easy to import sources, the models that you see here, and I'll go into in a second, are all imported from some kind of a source, right? There's very little that's ever really manually modeled in here. You take things like a Word document that represents, say, Etsy concepts, for instance. You upload them like the, one of our GS, like one of the SOL documents. Our system will entity extract and map literally things right from a Word document right through to really highly technical domains, an RDF graph, etc. You import them here, and the system will build out the graphs that you're going to see. So sort of going top to bottom, then you're looking at the view that our enterprise architect has, right? So what we feature is an upper ontology. So these two sort of generic system types and business concepts that are really a sort of a rich type system that applies across all verticals, right? We have a no-code platform here that provides the primitives for no-code domain modeling. Each one of these in the upper ontology is really a DSL for DSLs, right? So let's actually just pop into that for a second, right? So DSL for DSL, it radically simplifies modeling basically anything in the systems engineering domain. You can look at the graph here or individual objects if you want. We'll go into some of these graphs in more or less detail in a little while. What you see here are primitives that are sort of not specific to any domain. You see things like interfaces here that work with JSON. You'll see a bunch of different concepts for types of protocols, etc. And of course, this is a pretty rich domain. And at any time in the system, you can literally drive into something. I want to see what the protocols are in the upper ontology. And so I can just click on that element. And what I'll get is, a sort of profile about it. I can see at an ontology level, and I won't spend very much time here, but this is the way that you kind of model the hypergraph dimension. So the ways that these concepts link to one another. I'm effectively just telling at a high level the system that protocols here at the highest level could be SOAP, HTTP based, or some of the new things you see out of AI, like model, MCP or A to A, the sort of common things you see in agentic. We would like to be able to have anything that we model in our system be exposed through such an interface. Well, this kind of modeling allows that. If I look at the relationship graph, I can start walking through it. And again, I won't spend a lot of time on the detail here, but what happens that's really nice here is I can see effectively, what a protocol here can actually expose. So if I exposed it through, HTTP, it could expose a virtual function package. And as I start walking into it, I'll see, again, the kinds of things that might be connected or related to this object so that I can control it. So sort of stepping back, having that DSL for DSLs, we take that and we apply it to a vertical. So here, we're applying it, our enterprise web solution, networks.ai, has obviously a telco ontology you can see here. And what it provides is an out-of-the-box, harmonized, standards-based model that actually covers a number of subdomains that you can see listed down here. We've actually modeled the industry concepts from all the leading standards bodies into one unified model, and we'll pop into that in a second. But as you can see, each one of the standards bodies is represented logically by a sort of subdomain here. So it's not a subgraph or anything like that. We're taking these things and we're logically managing them with metadata. We're sort of tagging where a specific standards body's interfaces, for instance, might come from, etc. So I'll go into that again in a second. I'll drill into each one of these, but sort of working our way down, we have this generic type system, and then what we've done is we've applied it to Telecom. And if we look at the networks.ai solution, we of course everything in EnterpriseWeb has strong object models wrapped around every one of, like, everything is an object. And again, I'll talk about that in a minute. But just concentrating on the graph itself, what we see here is for the Telecom ontology, that base DSL we had now is extended, right? We start to see a lot of concepts here that are specific to telecom and are pretty important, right? If we start to look at things like tenant spaces, see ports and so on that are going to be related to them, we can actually start to see things like a CU, and the actual domains, etc. So again, what happens is, as you start to sort of explore a little bit deeper here, you get a very rich model that takes those kinds of core concepts we have and applies them specifically to things you're going to find here that make your life easy as a telecom, call it a developer, an engineer. Anywhere that you apply our system to, it's going to inherit the knowledge of this model. So if I pop into protocols here, as opposed to the ones you saw at the sort of DSL level, we start to see things like web, RTC, all these kinds of protocols that the system will now know and understand how to implement. And we see a much richer now kind of graph model that's built up around these protocols. When we look at a package now, those packages are going to be representing something that's actually coming from, again, from our telecom ontology. So what we get now is this kind of, if you want, a layering effect. So just to give you one more example of where this comes into play, is if we look at a specific telecom, right? A specific standards body that we're concerned with, right? Like the TM Forum, for instance, right? What we're actually looking at here in terms of their graph, their concepts are going to be things like BGPP, core, CPP data, etc. Dynamic, and again, these are going to be the concepts that come out of the SID. And so what we get is actually a graph here that's going to include, takes a second to render, all the ways that it connects the SID and all those elements that we don't really at a low level want to manage, right? So just to be very clear, we imported elements from the SID. The system helped us algorithmically match them or map them to these upper ontologies, and you can see the kinds of links through it, right? You can see all the blue dots here are actually things that came from that ontology you saw before. So we didn't have to specify low-level details about the SID. And when it came to interfaces, what we're talking about here is a very simple kind of, we point it literally at the interfaces that they're using within the TM Forum, right? So we can see how they implement them with protocols. Again, we don't have to write specific protocols for them. You see all the open API groups. And so what the system's able to do here is quite literally take it end to end, that if we care about TM Forum interfaces for integration, it can take any one of the ones that we've already mapped, and we took on, a Swagger doc, what have you, upload it into the system, it mapped it. It will create for us that TM Forum interface to do things like manage products, for instance, or allow ordering. And it will build all of the integration logic that we need, so nobody writes a single line of code at the end of the day when they're working with interfaces. So that's a pretty quick review, but it should give you a pretty good base of effectively how we're able to use this out-of-the-box ontology to support the operations of a telecom. So I'm going to now switch roles and show you how we actually do that, right? So I'm going to switch into what we call our service manager, right? So another one of the modules, and again, it's used, as the name implies, to manage services. All right, so what I'm presented with here is a very different view. Those ontologies that you saw, they're behind the scenes. So all those models are driving what you see here. And I'm going to show you how they link up in a second. But as a service manager, really what I want to do is design, deploy, and manage a service. Right, so what I'm provided with is a catalog of objects, you can see here, that represent physical and virtual elements that we might have onboarded. And you're going to see this kind of theme sort of repeated, right? With network managers for managing network elements, etc. Each of these objects is model driven in terms of onboarding. So we take any files, just like I talked about with taking RDF or what have you to build out the ontologies behind this. Here we're taking things like scripts, images, tar files, mops, etc. We're uploading them into the system, and then what the system's doing is that same entity extraction and dynamic typing. If I click on any one of these elements, what we see is actually how the system's applying those common methods from our ontology, right? So every object, first of all, gets wrapped in a case. High-level metadata, logs, the ability to actually, do fine-grained security if I want, versioning, and so on, is all going to be attached to every one of the objects in our system. So you get common management, control, auditing, all those kinds of things against everything. All right, so that's good. But once you get a little bit further down, what you start to see is that each one of these objects is dynamically typed, right? So this happens to be a network function, for instance, right? And you'll see the typing will go even further down. But what happens is that this type system that you saw in the ontology drives everything in terms of, sort of what is here, which is going to be, models of actual application behaviors, these things. This is a Aether stack from the ONF, right? So this is a 5G RAN and core. So you can see things like component models that you'd expect to find in that kind of an element. You'll find a cloud native profile. You'll see that it's mapped properties for the particular element, and importantly, it's also generated interfaces, right? So this is a set of standard interfaces like the ones I showed you. There was some TMF. Now there's some ETSI that are applicable here, and again, it's generating each one of these endpoints as a full. If you wanted to use EnterpriseWeb sort of as a standalone, just old school VNF manager, we're exposing the APIs so you could do that. You get a lot more benefit from using the full system, but at every point where it could be relevant, we're going to generate and provide those APIs. And again, just to emphasize, without writing a single line of code, leveraging that graph model that you saw earlier. Behind this,
Bill, if I could just come in for a second, just to summarize. So onboarding into EnterpriseWeb, so you take any heterogeneous element, but we're not just onboarding XNFs, VNFs, CNFs, PNFs. We're also modeling your target hosts, your cloud. If you're using cloud providers, we model those endpoints. We've already done that. They're already included in the networks.ai model. And what happens when we model those things, like I said, like Bill said, you give us the whatever you can, the tar files, the mop files, documentation, right? You give us an API, and the system will introspect the API. It'll do everything it can to pull out as much information as it can based on what's provided, and then to dynamically type the object, say, okay, well, I pulled this information out of what was provided. I dynamically type the object. It's a 99% certainty that this is a router or a switch, or whatever it is. Then it autofills standards properties, because we know that the vendor functions aren't standards based. Certainly the cloud native interfaces aren't standards based either, right? So it's going to autofill standard-based metadata. It's going to wrap them in the standards-based interfaces. And this way, from a design and management perspective, the telco can do everything through a standards-based interface. As Tom had mentioned, that single pane of glass, that unified control plane, you do everything through standard-based terms, standards-based metadata. And even though we know that the underlying things that we're connecting might have proprietary CLI, they might have unique idiosyncratic properties and behaviors, and it goes back to the ontology being sort of this universal translator, right? Sort of the Esperanto, right? It's sort of translating between all the elements. And so if you say I want a router, object.router.Sienna, it finds the Sienna router, it actually sees it. It then it'll drill into the Sienna object to see if there's any unique data, properties, behaviors, constraints, dependencies, etc. So you can find everything through a common index. You can discover everything. You can compose everything the same way. You can manage everything the same way, because we're effectively sort of doing a minimum viable normalization to the ontology. And if we can't normalize it, we just need a minimum viable when we do a validation against that. If we can't, the system will flag what it needs. So to say, well, we need a bit more to be able to handle this. And so it's going to sort of drive in that model-driven process to get a validated object interactively with the user. I mean, it's actually so simple, you can actually expose this interface to developers on a controlled security basis, where the vendors can be uploading and updating their own objects into your catalog, given if they have permissions. And then you would have those objects normalized in your catalog. And they could be validated as well as tested dynamically. So just wanted to sort of summarize what Bill was describing there. Go ahead, Bill.
Okay, thanks. So behind this, of course, is that graph model, right? And at any time as a developer, I can pop into it, right? I don't have to, but it's there, right? So what I can see actually in this case is how each of these objects are mapped to that domain model, which is obviously a common abstraction that lets us handle the heterogeneous nature of these objects. It lets them be discovered, composed, configured, and managed in the same way. And if I were to drill into this, you're going to see a lot of links back to things that are sort of really important for this particular element and are coming from that object model, right? So I don't have to implement specifically, LCM operations. It has ideas of plans for how it might generate a scaling event or et cetera, or the kinds of operations behind it. And it has the ability to, manage individual components based on the kinds of, again, things like interface standards for 5G and so on. It'll have all the tie backs that it needs so that it can, have full control of the automation of this object, including its management as well. So now what I'm going to do is I'm going to make use of this, right? So I'm going to make use of the fact that I have effectively a bunch of building blocks here in my catalog to build and design that service that I wanted here and to deploy it. So I'm going to have a simple conversation with the system to do that. So let's go ahead and do it. Show me a list of service templates.
Working on it.
Show me the graph of a standalone 5G core.
Working on it.
Add a virtual router. Add a virtual router.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose network service template.
To do this, I will create a new network service template named Secure 5G Core with IMS. Add an instance of EtherStack for core. Add an instance of FortiGate to provide the next-gen firewall. Add an instance of Camelio to provide the IMS. Add an instance of Vios to provide the virtual router and add EnterpriseWeb for core management. Would you like me to proceed?
Yes. Yes.
Okay, working on it.
Okay, so what the system did was it put together a minimum viable service for me. It's when we say minimum viable, it's already executable and everything like that. But based on those choices I had, that simple conversation and the graph models, it was able to, compose the service itself, even drill down and do, all the kinds of, advanced capabilities that our system supports, to the point of things like being able to realize that if I have a secure if I have a next gen firewall, I can secure the control plane. I can go that step further that people don't even realize about completely securing the infrastructure behind this. So it becomes an easy toggle in our system, and then we see anyone who's familiar with those standard interfaces will see them listed here. I can go and put in parameters for affinities and so on, what have you. But really, what I get is a fully configured service out of the gate with even things like properties that are going to be mapped in based again on the kinds of service that I'm creating, the right SLAs in this case that I might want to be managing, and what thresholds are sort of considered good. But beyond that, and of course, again, generating relevant standards-based interfaces, what I'm getting is actually the sort of, if you want, the operational aspects, right? The day one and day two plans or deployment and management are actually generated out of our system. So it takes the service topology and any configuration, and it actually builds for me what's going to be this event-driven process model. We call it a state chart here. And it's the tasks that you see that are required for doing the deployment. And each one of these is going to be connected based on policies and conditions. The processes themselves are async, concurrent, and massively parallel. The agents are going to handle the deployment with no manual integration or configuration. Each one of these, once I point this to a specific service, and as I mentioned, it's a infrastructure independent service at this point, right? I will bind it later, so it will figure out what exactly the configuration needs to be for that particular target. All that'll be worked out, and when we said it's massively parallel, you can do this, for your hundreds or thousands of events all in parallel at the same time. That's the advantage of this kinds of modeling. Now, the thing is, besides this, right, with meaning the day one plan, we're actually going that step further, right? We're generating also the day two plan, right? So the management plan that's going to sort of follow on. So it's not like we just deploy it and forget about it. It's going to be under full management, and it's going to use, our ability to actually provide what is really a semantic layer to observe this service as it runs, all of its KPIs and everything, figure out its health, and create things like really that autonomous networking. So we're going to be doing AI ops later. That's going to be driven by the plan that you see here. And again, this was driven or generated by the system based on its service topology, SLAs, KPIs, and other policies. I'm just going to move a little bit faster here. And the agents will stand up observability along with this. So what's important is we're not going to have to go in and configure an observability stack or anything like that. It'll all be part of it. So I want to get this thing, deployed. We could, and we do, enforce things like testing services, but for the demo, I'm just going to go ahead and serve this to my catalog, and then I'm going to deploy an instance. So we're going to order an instance of the service. And again, you can do all this through AI interfaces. You can talk to the system, what have you. But I'm just going to identify my local OCP cluster, so this OpenShift AI that I want to deploy to. The system's going to deploy it here in my dashboard, and within a few seconds, this is going to be actually up and running, and then we'll be able to actually do a little bit of experimentation with the service itself. So just give it a second here. There are a few things to actually note before I jump into demonstrating the service running itself. The one is that our system, as we mentioned before, is capturing literally a to the element kind of trace of every single operation that's being done. So you can actually see that in this kind of a case, via our web portal, we ordered the service and everything that happened. And this is really executing that plan you saw a moment ago for deployment. And, of course, we can leverage the graph at any moment. We can see, okay, what are the things that were related to core, for instance? What were the elements in this solution? So what subnets were connected, et cetera, what have you. But we get that kind of fine-grained ability to really examine these logs at whatever space we need. Nothing escapes audit. There's going to be a graph, deployment graph. There's going to be the kind of VDU health you'd expect to be able to see. That's all good. What I want to do now is just go into the observability itself for a second. So again, observability was set up. So I'm going to show for the demo, I'm going to actually run this service without AI ops activated, so you can see what happens in a sort of before and after scenario. So right now I'm just going to use the service. So let's place a quick call on my phone. I should apologize to here. I'm just in a public place here, so if you hear any background noise. But let's go ahead and actually place a video call here. So what I want to do is I deployed the service without AI ops activated, so you can see the before and after effects of our autonomous networking agent. Right, so what I'm going to do is I'm going to simulate a bunch of traffic here. We're going to see what happens.
Attention, poor performance detected for a service under management.
So a couple of things happen, right? The system, you can see all of the observability detected the attack, right? I'm literally flooding the service. The system itself with, in this case, a bunch of traffic. The service is overwhelmed and fails. You can see that we couldn't place our phone call anymore. And the system right away recognized that there was a problem and started root cause analysis based on effectively everything that was in the system. In this case, it's just identifying that AI ops policies aren't activated. So I'm just going to go ahead and do what it tells me. Activate AI ops day 2 policies.
Day 2 policies activated.
So what happens now is you can see that the system has identified it as healthy. If we go back to any of the sort of, proof of the pudding, right, we can see that our observability has, detected. It's all nicely back in the green. We can see our latencies and so on are being observed at a good pace. If we go back into the phone itself, we'll actually be able to see, if we go into it, that as soon as I go back into the app, everything is working again as expected. So that's all good. In the system, though, we can actually see what happened, right? So we can see that there are a stream of events that are actually happening here in the service continuously. And this is when we talked about low latency and so on, interfacing with an LLM. There are micro adjustments that are going on continuously now to keep that optimized service. They're all happening in real time. And you can see the flooding in here, one by one. If we go into them, we get that same kind of level of, trace, right down to the point of what was this? It was a predicted change based on temporal, right down to the fact that we interfaced with the LLM. We used only 2 input and 1 output tokens to make this sort of consideration. It meant we needed to change a P gateway. We needed to scale it out in a particular way, and we calculated what the element changes might be, right down to, again, tracking all the config changes, so you get that full audit. So what you get is something that's tracking and literally is going to manage this service going forward. Now, this is all good, and this, as far as a service manager, I'm pretty happy. I can even observe, again, the AI interactions. The conversation I had with the system is even tracked. So again, nothing escapes the AI, or sorry, the system's control, and everything's being driven by that graph model. But here's where it starts to get really exciting, right? Is that if we look a little bit further, we play a slightly different role, which I'm going to play right now. I'm going to play the role of a NetOps engineer to show you what kind of becomes another view of that same service. And again, with a whole bunch of additional capabilities, right? So I play that role. I go in as a NetOps engineer. And what I'm provided with first is a dashboard literally filtered to any faults that might be existing currently in my network. So I can see that there's some services and pods that might have had problems right now. I could fix them right from my dashboard. So it will literally take me into any object. If I want to see this particular container and how I might fix it, I can sort of pop in and I'll see right away the same kind of idea of extending a case around it. So I get full visibility of what's going on. I can get a peek at what state and telemetry, what might be a problem, and even have the system suggest fixes, like remapping a port might fix this particular element. You can see it's very easy for me to manage and fix my network. Now, I can even find things like, let's just say, I want to find the services here, and I want to see that service that we just deployed. I can see it actually right here in my dashboard, and I can get a bit of a different view from a network perspective of what this thing looks like. And again, it's overall state and telemetry. I can start to see a network graph of this particular element. So again, leveraging graph, or I can do something that's really exciting here, which is I can get literally a visualization of the entire network if I want. And this is leveraging my graph. So this is something I can slice and dice in any way that I might want. So if I want to see, if I want to see things that are related to the core, for instance, I want to see things in a particular cluster, I care about ports or I don't, I can start to sort of, if you want, shuffle my view around to find the things that I care about, identify what might be an issue and what be causing a problem. And just like that inventory graph view, I can drill into it. So there's two things I can do here. I'm going to show you here that are really powerful at sort of the end point here. Is we talked about semantic, sort of a semantic layer. I just mentioned it a little bit, and it's one of the end games that everyone in agentic wants. They want these MCP servers that they take weeks to develop to expose a specific interface. Well, here in EnterpriseWeb, you get something that's sort of the equivalent for free, right? So I'll show you this by, we'll just, I'll drill into something quickly here. I just want to see my services, right? So these are the services that I have here. I can see a couple of services that are already deployed, and I want to pop into any one of them, right? So this one is having a problem. So what I can do is I can pop into that service. I can see it has a fault, and again, I can chase down the issues with it. But if I want, I can actually expose what we call a network proxy interface that will give me a full story on this service. So it'll give me literally a blurb of what this is, a container-based service, and it was a 5G core, what it is, descriptions all the way through. I can see every single element of it. And this is, the kind of, I say the kind of metadata and at a glance that people really want. You just don't get by scanning something like a CloudWatch or what have you. And this exists automatically for every service. Now, I'm going to take this as my sort of final act here. I'm going to show you what happens if, I have let's just say I'm playing a real NetOps role here. I have a EKS cluster. I have something in Amazon. So an AWS tenant has a problem, and I don't know what it is, right? I can literally come into the system, and through our onboarding process, I can I can upload a simple kube config that lets me touch the control console on that EKS cluster. Right. And what I get is the system algorithmically maps it. It looks at it, says, and this is a good example of everything in our system. It says this is probably a network source aggregator, and this is probably coming through an EKS cluster with a percentage likelihood. Once I confirm that, the system does everything else I need to be able to observe and map all the objects that are in that domain. And you can see it gives me things like it spits back out the config, it gives me a snapshot. It'll tell me what elements it will potentially help me manage. And once I add that to my catalog, what I get is a much more capable system, right? Like within a couple of clicks here, like that was only a couple of seconds of work. I can come in and say, okay, well, what's the cluster that I'm working with? Okay, let's look at that cluster. Okay, there's a view of, there's a problem with the router potentially, right? There's a service here. And again, I can do the exact same trick that I did a minute ago. A service I knew nothing about prior to this demo and uploading it. System discovered it, and it didn't just give me back that these are containers. It gave me back that kind of semantic view. That network proxy interface tells me what kind of a service it was. It was an IMS. Right, from a particular vendor based on, again, characteristics, and it identified things in the map and gave me, again, goes on forever, all the data I could ever need as a snapshot in time that I could feed to an LLM if I wanted to, or just use for my own observability. So right on time. Thank you very much. I hope that wasn't too fast for everyone.
Well, the good news is I think we'll be recording, right? So people can to IWPC's catalog, and they can retrieve, I think, the slides and the video, right, Tom?
Yeah. Dave, you want to put up your final slide if you have a contact or anything on there? But
Sure.
while you're doing that, so they just real quick, a question from me. So if you're buying a system from one of the big OEMs, Ericsson, Nokia, Samsung, Huawei, whatever, this will overlay that and work on all the stuff that they're providing. And is there like middleware in between that you're kind of managing? How it's
Yeah, I put up the slide. Is it there?
Yep.
Oh, okay, perfect. So we will just plug into. So we're deployed in tier 1 environments, and so we connect to whatever the customer tells us to connect. I mean, the nice thing about the ontology, it's not opinionated, right? We don't tell the telco anything. We're actually just providing a useful service that they can deploy on premise, deploy it in the data center at the edge or on a base station that will help them do end-to-end automation. What the elements are, who they want to play with, who their vendors are, what their services are, how they construct slices. We're just an enabling technology. That's really the way to look at it. So we're sort of agnostic to the things they connect. But what we really are doing is eliminating like vast amounts of what you would call boilerplate code, the things that developers do again and again and again for every discrete service, for every instantiation of observability and AI ops. And of course, in the current setting, I don't know if there's any telcos that really have this kind of global visibility. Not that I've talked to. I think they all want it. That's a great point. I mean, yes, we work with their NEPs, Nokia, Ericsson, their hyperscaler partners, including like we discussed in your earlier question, if they have existing tools they want us to work with. A good example is, I said we're Red Hat partners. We work with telcos that use Ansible. They have a lot of playbooks. Now, we do workflow on our own directly as a serverless function, so we don't need Ansible. The platform doesn't need it. But the telco has all these playbooks, and they don't want to throw them out. They represent value and effort. So what they use EnterpriseWeb is as a trigger. EnterpriseWeb's evaluating conditions, and when an event happens, it triggers the execution of a specific Ansible playbook, and the state flows back to EnterpriseWeb. So we can play nicely with whatever the telcos preferences are and initiatives are. Again, EnterpriseWeb really itself is like a utility, right? We're trying to take away what's really the wicked hard stuff, the stuff that you do redundantly, the stuff that's tedious, the stuff that eliminating the stuff that gets in your way, and sort of delivering what I think is actually the first realization of the horizontal architecture anticipated by 6G, right? Horizontal, serverless, microservices based, cloud native, event driven, AI, AI first, all of those good things. It's all in there, and so we're giving people sort of a platform. And one thing if you don't mind me adding, Tom, is all of this can run headless. So in other words, EnterpriseWeb itself is API first. So if the customer has its own enterprise portals, its own internal portals that it wants to use, that's no problem at all. You can control EnterpriseWeb through API calls, and 100%. So again, we're trying to enable telecom futures. We're not trying to get in the way of anything else, right? However they want to use us, however we best serve a need. It also means that telcos could sort of start small, sort of think big, but start small. They can start with a use case that's relevant and pressing to them, and solve that problem. And then because of the nature of it, because we're horizontal, we're not building stacked, siloed solutions. They could just keep on extending the abstraction, right? They can continue extending the use of the graph, or the ontology, to more use cases and in more environments with more elements and services. And so platform, like Bill said, it's 50 megabytes, deploys out of the box in minutes, presuming there's an environment for us. It can run anywhere. It could run literally at the edge. 50 megabytes, it requires no third-party gateways, queues, brokers, integration tools, automation tools, orchestrators. So you get a full automation solution, AI-powered automation solution in 50 megabytes that can run at the edge. We could run on a CPE. We could run on a laptop. That's what Bill's doing right now. He's running it on a laptop, and with an LLM, right? with Granite 3B. So I know we ran over, but Tom, if you'd allow, I'd be happy to answer questions if there's any.
Yeah, I don't see any, and actually, I think you guys did a great job explaining this and making it easy to understand, even for a non-network guy like me. I think I get it. But no, very, very cool. Good job, Bill. And everybody, you've got Dave's contact info there if you have any questions, or feel free to reach out to us and we'll get you hooked up with them as well. So Dave, Bill, thank you. Great job. And hopefully we will see you guys next time.
Great. Thanks, Tom. Appreciate it. Thanks, everybody, for your time. Cheers.
Cheers.